Alright, this is a cheat sheet for letting you know the dimensions of a matrix. For example, a matrix that is M by N with a rank of R is going to have the following properties. Just in case there's any question, the rank of a matrix is based on, once you do your row reduced echelon form, you get something like 1, 1, 0. Maybe all you have are zeros down here. Well, this would be a rank of 2. It doesn't really matter what these are. But basically, the number of pivots you have determine what your rank is. So if you had another 1 down here, then that would be a rank of 3. But here we would have a rank of 2 because we only have 2 pivots. So the number of pivots you have once you have your row reduced echelon form will determine what your rank is. So let's say, for example, we have a 6 by 4 matrix, rank 3. Well, that means that we have 6 rows and we have 4 columns. But the rank is going to be 3, so once we get to the row reduced form, we're going to have something like this. And then we're going to have a bunch of other zeros. And then we're going to have some other column over here that we don't really care about. But you can see we'll have 3 different pivots. Well, the dimensions of the column are just going to be R. The dimensions of the row are going to be R. And you can clearly see it, looking at this. You have 1, 2, 3. But the null space of A is going to be the number of columns minus R. So in this particular example, we have N is equal to 4. So N minus R would be equal to 1. Let me just write this down. So we have R is equal to, in this case of a 6 by 4 matrix, rank 3. R is going to be equal to 3, therefore the dimensions of the column are going to be equal to 3. And the dimensions of the row are also going to be equal to R, so that's also going to be 3. The dimensions of the null space of A are going to be N minus R, which is the number of columns, which in this case is 4. So that's going to be 4 minus 3, which is 1. And then the null space is going to be M minus R, which is the number of rows that we have minus 3. So that's going to be 6 minus 3, which is going to be 3. So this is the null space of the transposed matrix A. And here's just an extra question. Suppose V is spanned by 5 independent vectors in R7. Determine the dimension of B and its orthogonal complement V perpendicular here. So we can see that it is spanned by 5 independent vectors in R7. Which means the basis has 5 vectors in it. But we again remember that the dimensions of B plus the dimensions should be equal to the number of total dimensions, which in this case would be 7. So essentially it's just 5 plus dimensions of B equal to 7. So the answer to this question is going to be 2.